Okay, question 7 says the table shows the values of x and y where y is equals to log with base 10 x plus 5 for x values between -1 and 4. Okay, using trapezium rule, with all the y values in the given table, show that this log with -1 to 4 limits is approximately equals to log with base 10 of k. Okay, so what do we need to do? We need to first use a trapezium rule. So first write what is a trapezium rule. It is integral from a to b y of dx, like y dx, applying integral on y is approximately equals to h over 2 times y naught plus yn plus 2 times y1 plus y2 up to yn minus 1. Okay, so we need to substitute all the values, but for this all we need to understand firstly what is h. H is b minus a over n. So what is n now? N is not this 1 2 3 4 values. No, n is not this, but the region in between, 1 region, 2 region, 3 4 5. Okay, so your n is 5. It's like when you have a graph like this, okay, it's starting from x values -1 to 4, like this, from -1 to 4. So what it is giving us, if we distribute it into, like from -1 to 0, this is one region, then this is 1 to 2, 2 to 3, one second, 1 2 3 and 4. So how many regions do we have here? This is 1 2 3 4 and 5. So this is your n, how many regions it is divided into. Okay, so here n equals to 5. So when n is 5, what do we do? B minus a. What is b? This is the x value, this value is b, this is a. So 4 minus -1 over 5. So we'll find h to be 4 minus -1 over n is 5. So this we will get to be 1. Okay, this is h. Secondly, we need to find what is y naught and yn. So this value, the very first y value, we set it to be y naught. Okay, and the last value is, we set it to be yn. And this, from here it is y1, y2, y3, y4. Okay, whatever, how many number of terms do we have up to yn minus 1. So let's substitute all these values in the given formula. We will be getting h over 2 means 1 over 2 log of 4 gives you 1 over 2 log with base 10 4. This is your y naught, plus yn is log with base 10 of 9. plus 2 times the rest of the values, log of 5 plus log of 6 plus log of 7 plus log of 8. Okay, these are all values. Now, yeah, also with base 10 all the way. So when we will be solving this all, what we are actually having, we are having two logs with the same base, two numbers adding. So when we have this, what do? Log of a plus log of b with same base, let's say 10, gives you equals to log of ab, the product. Okay, so this is your formula that we know about, so we are going to use this. These are your formulas, so I'm writing them like this. Okay, now applying this on these terms and these two terms, so it will give you equals to half of log with base 10 4 times 9 plus 2 times log with base 10 5 times 6 times 7 times 8. Okay, now we can just multiply them. Okay, and secondly also we can multiply this 1/2 outside inside, so we will be left with 1/2 log of base with log with base 10 of 36. 4 9 times is 36 plus 2 and 2 got cancelled, so we are just left with log with base 10. Okay, what is 5 times 6 times 7 times 8? We can calculate this, so we get it to be 1680. Okay, now when we have something in the start like some power, what do? N times log of m gives you log m power n. Okay, so this is all of it. This is also your formula, so I'm writing this out. So let's apply it on this part. It will give you log with base 10 36 to the power half, which is going to give you, what is the square root of 36? It's a complete square. 36 is a complete square for 6, so it will give you log with base 10 6 plus log with base 10 1680. Now what we will be doing again, if two logs are added up with the same base, their middle, like the inside term, is going to be multiplied. So log with base 10 gives you 6 times 1680. So what it gives you, 6 times 1680 is 10,080. So this is giving you log with base 10 10,080. Okay, that's it. We needed to just solve it till here, where they said it should be approximately equals to log with base 10 k. So what is k now? Your k is 10,080. Yeah, okay, this is all of your working for your this question. So now find the value of a such that, now we need to find the value of a when we have log with base 5 minus a minus log with base 5 a plus 25, and it should be equals to 1. Okay, so just solve it out. What do we have? 2 times log with base 5 . Okay, so solving this is your part B. We know whenever two logs are being subtracted. Okay, first we cannot solve this. Let's first apply the power thing. So this will go in the power, so it will become log of 4 log with base 5 minus a to the power 2 minus log with base 5 a plus 25 equals 1. So when we have two logs that are subtracted, so similarly as we know that when we have two added we multiply them, in the same way if two logs are being subtracted, so they give you the division of a and b, so it will give you log a over b if you have log a minus b. Okay, so this is your thing that you're going to apply on these two. So it will become log with base 5 minus a square over a plus 25 equals 1. Okay, now how do you solve it? We have 1 over here, so what you can do it to be, we can take this, like whenever you have 1, it means you can write it as log with the same base and the same number. So if you have a log like this with same base and the same number, it is equals to 1, and that means like if you have base a and the number a as well, so generalizing it, so we are putting it equals to log with base 5 minus a square over a plus 25 equals to log 5, like base 5 and 5, so it will give you, like you have same log on both sides, so you can cancel, so you're left with 5 minus a whole square over a plus 25 equals to 5. Now simplify this, you will get it to be 5 minus a square equals 5 times a plus 25. Okay, and then 25 plus a square minus 10a equals 5a plus 125. Okay, and this will give you a square minus 10a minus 5a, it would be minus 15a, and 25 minus 125 would be minus 100 equals 0. So what we needed to do, we need to find the value of a. Yeah, so we get a quadratic equation now. So how do we solve this? minus 100 times a. So we'll get the factors to be like, if we break the middle term, or you can use the quadratic formula as well, but I'm using the breaking of middle term. So which two factors when added up should give you minus 15a, and when multiplied should give you minus 100a square? So it must be some bigger number with a negative sign. So minus 20a plus 5a, so it gives you minus 15a minus 100 equals 0. So a times is a minus 20 plus 5 times a minus 20. So this gives you a minus 20 times a plus 5 equals 0. So this implies a equals 20 or a equals minus 5. Okay, now how do we check the values for it? We need to go for like checking the values. You can check a equals to minus 5 and a equals to 20. So for 20 it will be 5 minus 20, so it will be minus 15. So log of minus 15, and 20 plus 25, so it will give you a positive number, it's fine. Secondly, minus 5. If here is minus 5, so 5 minus minus 5 would be 5 plus 5, 10. Okay, and secondly, if you will be taking minus 5 here, so 25 minus 5 will be 20. So if we could see, only this way we are getting a negative one. So log for a negative is not going to be solved, so we will be taking a to be equals to minus 5, because 20 is giving you a negative log for log, and that is not supposed to be solved. Okay, that cannot be solved. So this implies a is equals to minus 5, and this one is rejected. That's all about your question 7. Okay, I hope you get it.